This topic is one I'm very interested in handle because by learning about smart factory industry 4.0 will help me manage and optimize all aspects of manufacturing processes and supply chain to access real-time data and insights.
Correct, Arthur. I think let's not keep the participant waiting, shall we? I think without further ado, let's introduce our moderator for today's first panel session, Dr. Rahmatul Istifarin. Dr. Titi, is Dr. Titi already in the Zoom yet with us?
Yes, I'm here, Amil and Arthur.
All right. Okay, so Dr. Titi is also one of our lecturer in Industrial and System Engineering Department. I think for Miss Titi, the Zoom is yours.
Okay, thank you. So I meet you again. So I was moderator also yesterday. So for today, I will introduce myself once again. My name is Rahmatul Istifarin. You can call me Rahma or Titi. I'm lecturer from Industrial Engineering Department. And for today's agenda, we will have presentation with Professor Engineer Dr. Azwan bin Abdul Rahman from University of Technical Malaysia Melaka about smart manufacturing and industry 4.0. Good morning, Professor. You already here?
Yes, good morning.
Good morning. Is in Malaysia is 9 p.m. right? For now?
9 p.m.
Okay.
9 a.m. sorry.
Okay, let me read your resume first. So, Engineer Dr. Azrul Azwan bin Abdurrahman is senior lecturer from University Technical Malaysia Melaka in Manufacturing Engineering program. He did his PhD, also master degree in TU Berlin, Germany, in Assembly Technology and Factory Management. And his research focus are integrated manufacturing system, automated intralogistic and control system. So, are you ready, Professor?
Yes.
Okay. Okay, you can maybe try to share your screen.
Right, I will do that now.
Okay, maybe before we begin the presentation, I will inform you the time for your presentation is 45 minutes and there is a Q&A session in the end for 10 minutes and the participant free to type your question in the Slido that the link will be shared by the committee in the chat box. So I will inform you if the time is up 10 minutes before time is up. Okay, it is clear or any question?
The moderator, is it possible to
Pardon?
see my?
Still black in my screen.
Okay.
Do you want us to help to share your screen? Maybe. Professor, are you still here? Okay. Okay, I can see your screen now. The Zoom is yours. Thank you. You still muted, Professor. I can hear your voice. Okay.
Thank you so much for the moderator, Ms. Rahmatul, and also to the Master of Ceremony, which is the two MCs just now. So once again, I would like to thank you to invite me to give a talk in the plenary session 2 in the summer camp of Engineers 2022. And today I would like to share a little bit about my knowledge regarding the smart manufacturing and also industry 4.0. I believe for this summer camp, the theme is quite interesting, which is smart device. Let me check. Smart technologies as an enabler of global industrial excellence in industry 4.0. So I hope by having this kind of plenary session, you will get a better idea what is a smart manufacturing, and also regarding Industry 4.0 then. I understand that most of the participant is from third year and also the final year. So I believe some of the knowledge on smart manufacturing industry are already there, but I'm going to make sure that you have the same understanding and same knowledge as what I have regarding the smart manufacturing and industry 4.0 then. So for today, I'm going to talk a little bit about the introduction. I'm going to start my presentation with the introduction, giving some idea why all this happened. And after that, I'm going to take a look deeper into the Industry 4.0 itself. And I'm going to touch a little bit on two main characteristics of the smart manufacturing, which is the reconfigurable manufacturing system and also cyber physical production system. Along my presentation, you're going to see why I'm going to focus on these two elements, which is reconfigurable manufacturing system and cyber physical production system. And at the end, I'm going to show you what I and my team have done related to this topic then. I hope this is going to give you some idea on this smart manufacturing and also Industry 4.0. And I would say that I hope you're going to get an interesting presentation then. Okay, let's take a look at in the introduction. So nowadays, I believe all of us agree that our life is deeply affected by many new technologies which have reached a sufficient level of maturity. We can see that nowadays we have a high-speed wireless LAN. We're going to have LTE, 5G. All of us, I believe, we have smartphones, tablet, notebook, and all these devices able to recognize the speech interaction, gesture control, virtual reality, augmented reality, and also nowadays most of the people are not interested to use the telephone anymore, but prefer to have a VoIP rather than a telephone then. So all these things leads to what we call the Internet of Things. So by having this Internet of Things, we can say that leads to information will be available anywhere, anytime, with any content for any user using any device and any access then. Let's take a look at a short video related to the Internet of Things.
The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data? And how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications that address industry-specific needs.
So you can see that it's all started with the device that connected to the Internet of Things platform, and by having this connection, then all the data can be transmitted, and then we can analyze this data in order to get a better information and also some knowledge then. So you can see by having this Internet of Things, everything's getting smarter. So starting with the smartphone, and then looking at the smart homes, people are request for the smart car, and definitely as a manufacturing engineer or engineer itself, we would like to have a smart factory also. So in order to have this kind of technologies, we need to have the technology push and also market pull. If you can still remember, in the year 2000, there's a smart refrigerator has been introduced. But at that time, this technology already pushed towards the market, but there's no market pull. The refrigerator itself costs around 20,000 US dollar. So nobody would like to buy it. Even though it's smart, it can recognize what kind of things that required to be top up, and then it will connect it to the internet, and then it will order by itself. But somehow there's no market pool, and also at the time the price is too high, then the sales or the refrigerator itself is not success then. So you have to remember that in order to get a smart factories, it's not only the technology push, the market pool is also required then. So at this time, I believe there's a technology push, and also the market pool is getting higher then. So in order to have a smart factories, we need to know what exactly is the smart factory. And related to our topic today is smart manufacturing. What exactly is smart manufacturing then? So let's take a look at a definition that I gather from some of the sources. A smart factory itself is a digitalized manufacturing facility that use connected devices, machinery, and production system to continuously collect and share data. This data is then used to inform decision, to improve processes, as well as address any issue that may arise then. So when we talk about smart factory, we are focusing on the facility. So the modern concept of manufacturing system required smart automation with vertical and horizontal integration. And this integration determines the foundation of Industry 4.0. We're going to talk a little bit more deeper into Industry 4.0 later, but right now, everybody, I believe, already have heard this term, which is Industry 4.0. So this integration is really the foundation of this Industry 4.0. So the smart manufacturing is the intelligent, real-time orchestration and optimization of business, physical and digital processes within factories and across the entire value chain. So it required the variety of technologies such as artificial intelligence, big data analytics, cloud computing, and also industrial Internet of Things. Based on the previous video, you can see that this Internet of Things, but when we talk about Internet of Things, it's not only covered in the manufacturing or industrial. For the industrial itself, it's required a little bit more secure in the Internet of Things. However, whenever we would like to talk about smart factory, we need to take a look at all the processes involved in smart factory.
Hello, Professor. Are you still there? Because in my device, I cannot hear your voice. Professor Azrul. Okay, I think there's an issue for the connection. I will try to reach him. Okay, he is not in the meeting. Maybe we wait just a moment. Okay, you already hear some of the material from Professor Azrul. You can ask something in the Slido if you want to ask about the manufacturing 4.0. And if you asking in the Slido with your name, you will get the point from the committee. So don't ask anonymously. Please write your name. Okay. Okay, because we're still waiting for Professor Azrul, maybe I can asking MC here, what do you feel about the material that already happened 5 minutes? Okay, Professor Azrul already here? Okay.
So, I'm so sorry, there's something wrong with my computer. I hope
It's okay, Professor.
suddenly it's restarting by itself then. So let me continue. Sorry so much.
It's okay. Just continue your presentation.
Let me share again. Okay, so right, you can see my screen, right?
Yes, yes.
So I'm sorry again, once again, I'm so sorry for that. So let me continue. So in order to have a smart factory, we need to take a look at all the processes of the factory itself. We know that in order to start producing a product, it's required to have a product development, and then it goes to the work operation. And after we have all the work planning and also work control, then we go to the manufacturing processes and also assembly. And after that, we sell a product, and then this goes to the recycling, lifecycle management, and so on. So we have to make sure that all these processes is covered in terms of this smart factory itself. It's not only that, we also require, in order to have a smart factory system, we need to have a smart worker too. That's why I believe all of you, the participant of Engineers 2022, is among the personnel that required for the smart factory system. But we have to make sure that the manufacturing goal must be the focus of the smart factory. So we know that to have a good manufacturing, we need to take a look at the 3 elements, which is the cost, the quality, and also the time. Even though the smart factory will give maybe a lot of benefit, but if these 3 objective of the goal of the manufacturing is not catered, then I believe nobody would like to go to the industry 4.0 technology then. So in terms of cost, definitely the customer would like to have a low prices. So the factory need to produce the low cost and also utilize at a minimum utilization at minimum cost. For the quality, this is where exactly most of the factory are moving toward the high technology facilities, which is to get a high quality standard and also to produce a zero defect delivery. So in this case, the factory looking for the integration of manufacturing and also quality control. So this is one element which lead to the industry 4.0 and so on. The same thing for the time. So the customer normally requests for the short delivery and to have a good facilities that covered by the technology of Industry 4.0, it will give a possibility to have a short development time and also short manufacturing and order processing time then. So let's move to the Industry 4.0 itself. So in order to take a look at Industry 4.0, let's move toward the evolution of manufacturing system. Looking at the starting of the manufacturing in 1850 and to 1913, mainly the manufacturing system are more focused on manual production. So people are tailored based on the order, then they're going to produce based on the personalized product. After that, in 1955, it's a peak of mass production with a high rate of production. Then in 1980s, there's some customization is allowed. So manufacturing system able to produce a mass customization production. And now in the year 2000, we can see that there's several directions that choose by the manufacturing company, either go for the personalization or regionalization or globalization. So looking at this evolution of manufacturing system related to that, we can see that now some of the company are moving from the dedicated manufacturing line to the flexible manufacturing line. And nowadays, in order to cater the personalization and a lot of changes in terms of the demand and so on, some of the researchers suggest to use the reconfigurable manufacturing system then. So we're going to take a look at what is the reconfigurable manufacturing system. Even though we have this kind of evolution, we can see, and I believe whenever all of you going to the industry, you can see that this problem are still there in the manufacturing company then, such as the workers spend time documenting process. Somehow, whenever we test our prototype, they're going to be serious flaws in the test. So the team are going to rectify this problem and start designing again. Even though some of the machine, even though it's still working fine, but it's under maintenance and so on then. So the current common manufacturing system, such as monolithic, fixed location with a wired and hierarchy architecture, with a subcontroller, and also unknown position of the product. So it's not able to cater with a shorter product life cycle, individualized product, international competition, and also quality demand. So everything need to be shortened, which is the setup time of our manufacturing system, and also the production process also need to be shortened. Due to that, in order to have a future manufacturing system, it's looking towards the modular, rather than monolithic, distributed control system, possible to change location for the resources, and also not only connected with the wired, but wireless. It's easy to change the position, and also the product possible to be sensed, or the position of the product itself we can monitor and track. So due to that, for the future manufacturing system equipment, we would like to treat it as a modular smart object. People are always related this to the Lego itself, because Lego is in a modular object, and it's also possible to make a plug and play in order to give or to develop a bigger system there. So this modular smart object need to have a unique identity and memory by birth. Then it's offer autonomy, can be located and monitored at all time, have a standardized network interface and link in worldwide network, can be described by model, and also to have all the required technologies that support Internet of Things. So these the people are looking into the manufacturing system equipment, need to have all these characteristics. Not only that, in terms of feature control architecture, we're not able to depend on the automation hierarchy anymore, but somehow we are moving toward the automation network. And based on that, we can say that the future of manufacturing system is combination of the advanced manufacturing system itself with the big data, and then with the cyber security in order to protect some confidential data, moving toward the logistic 4.0, mass customization or mass personalization, Internet of Things, and inside of the advanced manufacturing system itself, it requires some cyber physical system. It will connected with all the sensors in order to check the reactivity, traceability, and predictability. And also it will cover the resource of the future, which is not using the electricity directly, by using the alternative energy such as solar, wind, and so on. Then, so all these things leads to the term Industry 4.0. So at first, this term is Industry 4.0, which is originally from Germany. What we know about this thing is called the Fourth Industrial Revolution. But during the introduction of this term, people are saying, is it just another hype of industry, or is it really mean something then? So now people would say that it's not just a word, but it requires action then. However, whenever you talk about Industry 4.0, you have to really understand why this called the Fourth Industrial Revolution. After all the thing happened, now we started to say that, oh, now we are moving to the Fourth Industrial Revolution. What exactly is the meaning of Fourth Industrial Revolution? So I myself really looking into the real definition and why this thing is called Industrial Revolution. So we have to know that the industrial itself is focused on the business in producing goods, which is normally its manufacturer. And then the revolution itself is a very important change in the way that people do things. So as a conclusion with the Industrial Revolution, you can say that it's the very important change in the way that manufacturers operate in producing goods. And so if you compare nowadays with the previous one, maybe the third Industrial Revolution, what exactly changed? So that's what you have to think, why now we call it as a Fourth Industrial Revolution, and why what exactly is changed in terms of manufacturing goods or producing goods in this Industry 4.0 then. So we take a look at the common diagram of the Industry 4.0. We know that we understand Industry 1.0 whenever the mechanization is introduced. So the way of producing goods change then, because they have steam power, they have some equipment that based on the mechanized. So people are doing it differently. Then it moved to the Industry 2.0, which is when electricity is introduced. And at this time, people are introducing the production line, or based on the assembly line and production line, then it's possible to produce a mass production. So the way of producing goods are different. In Industry 3.0, where the electronic is introduced, then at this time, people are talking about automation, computer, and during this time also, people are introducing computer integrated manufacturing SIM system in order to cover or to do the manufacturing system or to produce goods. So we can see the difference then. Now, in the Industry 4.0, the term that always appear in Industry 4.0 is the cyber physical system, Internet of Things, and networks. So what exactly is the difference? So you can see that everywhere, if you're looking at the definition of Industry 4.0, people are talking about cyber physical system. What exactly is cyber physical system? So we can say that in Industry 3.0, we already have automation, we already have using the cyber part, which is the simulation software, the software that help in producing goods. But this software element and also the physical element is not connected, or not it's not synchronized in any way. Due to that, in Industry 4.0, they are looking at the possible combination of cyber and physical in working together in the environment, what we call it as the cyber physical system. And based on this cyber physical system, we believe that it's possible to have the data directly and to optimize the system I would say automatically, in order to get a better manufacturing possibility then. So in order so you can see that the engineering challenges keep getting bigger then. As you can see from the video, it shows that all the main target or the main goal of the manufacturing is still there, which is every time it change from industry 1.0, 2.0, 3.0, every time we try to get a bigger output to reduce costs and also to get a better system in order to produce the high quality product then. So you can see that in industry 4.0, which is the fourth industrial revolution, our main idea to have each equipment connected to the internet, and in order to have this kind of communication and also to analyze the system, we need to have a sensors. And you can see that if every equipment in our manufacturing system is having numbers of sensors, then we have to manage all this data and also to make sure that we have a better information out of this data. Then, due to that, that's why people are also talking about big data and how to manage that. So you can see that from this video, it's already summarized the industry 4.0, but the real definition given by the German itself. At first, when they introduced Industry 4.0, the definition of Industry 4.0 is referred to the technological evolution from embedded system to cyber-physical system. It's a decentralized intelligence help create intelligent object, networking, and independent process management, with the interaction of the real and virtual world representation a crucial new aspect of the manufacturing and production process. Why it's really important to make a connection between the real or the interaction between the real and virtual world, because through the virtual world, it's possible to make a lot of prediction analysis rather than we need to stop the real production system. Due to that, whenever we have the data from the real system, we can predict something with the virtual world, and then it's possible to send back the real optimized I would say the situation at the time into the real system then. So as I said earlier, it's coming from German. Definitely the idea to introduce Industry 4.0, the main benefit goes to the German economy at first, which is say that Industry 4.0 is a concept created as a technological innovation strategy to enhance manufacturing competitiveness in Germany. Because at that time, you can see a lot of companies, German company, moving to the developing country in order to set up their own factory and also to produce goods. So in that case, the country lose some of their income. So in that case, they would like to make a competitiveness in Germany again. So they introduced the Industry 4.0 in order to have their manufacturing company stay at the German. So it's help keeping the production in the country, help local companies to compete successfully, bring leadership on world markets, speed up, and so on. But however, this Professor Zulke, one of the initiator of Smart Factory, is one of the leader developing this Industry 4.0 demonstrator, mentioned that in order to have this Industry 4.0, it's required a long-term commitment. It's not only right now we are this happy with the current system. We're still in the middle of the Industry 4.0. A lot more technology need to be done in order to improve the system. And also to make sure that the main idea of Industry 4.0 realized then. So it needs a long-term commitment. It's a major uphill and not a smooth change. It's not a single industry solution. That's why most of the industry, especially in the Germany, they're working together in order to realize this Industry 4.0. And definitely it needs a new skill. And we hope you, a young generation of engineer, later will get this kind of new skill in order to support this smart manufacturing and also smart factory. Needs interdisciplinary collaboration and is closely linked to cloud and also big data. Okay, you can. I'm going to show a little bit about the history of Industry 4.0 in Germany when it introduced in 2010. After that, the first term used in 2011. So at that time, they're working on this, what exactly it means by Industry 4.0, and it come out with a final report from the government itself, and they come out with a platform for Industry 4.0 by 3 industry associations. And right now, you can see that they also have a roadmap starting in 2010 until they plan to have in 10 years a system that really used in industry. But I would say right now it's already 10 years. So it seems that some of the big company already implement some of the technology of Industry 4.0, but they have a lot more to overcome and to do. So you can see that based on this roadmap, they come up with the first demonstrator, and the demonstrator developed by the Smart KL Factory or Smart Factory KL. You can see from this video then.
Industry 4.0, a synonym for the production of the future, a production which can be adjusted quickly and flexibly to changed market requirements, and which makes economical production of customer individual products in smallest quantities possible. This is ensured through the implementation of state-of-the-art information and communication technologies and their networking in the Internet of Things, of services and of data. The human amongst the digitalized factory will continue to play an essential role. Thanks to his unique and creative abilities, he becomes the micromanager of the production processes. He outlines strategies, evaluates optimization potentials, and intervenes if necessary. He is supported by innovative human technology systems, which support him especially during highly complex and non-predictable activities.
For already 10 years, the Smart Factory is the pioneer of the intelligent factory of tomorrow. As a competence center and manufacturer-independent demonstration and research platform, the Smart Factory develops innovative factory systems in which the vision of Industry 4.0 has already become reality.
In a network of renowned partners from industry and research, we are working on new concepts, standards, and solutions which form the basis for a highly flexible automation technology. In 2014, we presented the world's first manufacturer-overreaching Industry 4.0 plant in a modular design in a consortium of selected partners. The basis of any Industry 4.0 realization are consistent interfaces. Besides mechanical standards, electromechanical and information technological interfaces, such as uniform plug connections or communications protocols, are especially relevant. The manufacturer-independent plant produces an intelligent product which controls its own production by means of an RFID tag and transmits its individual configuration to the different modules. This efficiently ensures production down to batch size 1. The smooth and quick transfer of all relevant data is possible due to industrial Ethernet from the backbone of the plant, modular infrastructure. Thus, a continuous and transparent information flow in real time is ensured. A scenario illustrates the relevance of the cross-system data transfer and evaluation. The modules integrated into the plant are recognized automatically, and the current status is continuously transferred to the integrated IT systems. If the status of the module is marked as faulty, the worker receives an automatically generated message on his mobile device. The modular structure ensures a simple and quick decommissioning of the according production unit. After the module has logged off and its gates are closed, the worker can remove the unit from the process. To bridge the gap, a bridge module is integrated into the production process. The workpieces removed out of the bridge module continue to be produced at the manual workstation, parallel to the maintenance tasks. Marketable solutions train or accompany the employee during the execution of the production step to be bridged. Parallel to manual production, the defective unit is being replaced. The maintenance and repair work is made easier for the worker by means of augmented reality. Smart glasses are used for instruction and support by overlaying what was seen with according recommendations for action. As soon as the repair tasks have been completed, the bridge module is replaced by the repaired cell again. The monitoring system recognizes that the module is available again and contains the current data. At the same time, the engineering automatically provides the suitable parameters to integrate the changed module into the process for quick and easy configuration. The production is completely taken over again by the plant. Our members and sponsors create a lively partnership to realize the vision of the factory of tomorrow. If you want to help create the future, we invite you to participate in this strong network. The Smart Factory offers you the suitable platform for this.
So you can see that there are a lot of industry involved in developing this kind of such demonstrator for Industry 4.0 system. So even though the system is proved to be working in the lab scale, but somehow until now, I believe there's none of the manufacturer are adopting this kind of technology directly, but they need some modification and also customization suit to the manufacturing system that they have already. So even though at first Industry 4.0 are mainly focusing at the manufacturing company itself, but whenever the economic expert mentioned that this thing is not only going to impact on the manufacturing, but is also going to affect the very essence of our human experience then. So due to that, not only manufacturer right now is focusing on Industry 4.0, you can see that even the service provider, service system also using technology that trying to develop the Industry 4.0 then. And not only that, you can see that most of the developed country already moving toward this. Whenever it's introduced by the German in 2010, so you can see that some of the country already moving, even though the term they're using is different, but the main idea is still the same. And we can see that nowadays, not only this country, but most of the other countries also are looking towards this Industry 4.0 then.
I'm sorry, Professor, the time 10 minutes more.
Okay, I will move, go a little bit fast then.
Okay, thank you.
So this is an example of implementation. Maybe taking a short video and after that presentation. Okay, I think I'm not going to move forward. So you can see that from this video, the thing that I would like to emphasize the outcome of this video is you can see that the way of manufacturing something has been changed whenever the product itself or the component itself already have some information inside of it. So in order to process it, so the way of manufacturing is already changed. So you can see that based on this kind of Industry 4.0 introduction, our country, I believe Malaysia, Indonesia, and also Philippines already have their own strategy in order to adopt with this thing. In 2018, Malaysia itself already emphasized on all these enabling technologies. Looking forward to have a better research and also development in this area. So this area that focus in the industry forward, what called by the Malaysian policy, Malaysian MITI, Industrial and Trade Ministry. So they are focusing on this thing, and mostly main of the research are focusing also on this area then. And I also understand that in Indonesia, they are looking into Indonesia, making Indonesia 4.0, and they already emphasize all these 10 national priorities. They have a way of doing or making Indonesia towards this direction. And also in the Philippines, they're also focusing on this roadmap. They're looking at the timeline, and each year they are focusing on certain technologies, and to make sure that everything is going towards this Industry 4.0 then. But anyway, whenever you're looking at the Industry 4.0, smart manufacturing, smart factory, there's a lot of buzzword or keyword that you need to understand a little bit. So my team, some of the researchers that working on Industry 4.0 in my university, trying to map what exactly it means by big data. Is it covered by the smart manufacturing and the Industry 4.0? Is it covered the whole smart manufacturing, IoT, and then you come into the intelligent manufacturing term, virtual production, and then CPPS, cyber physical production system. What is the difference between the cyber physical production system with the CPS itself? And then we're going to take a look at the term like a social machine, smart system, digital twin, IoT, and so on. So this is somehow we try to map in order to understand what exactly is Industry 4.0 and what the difference between Industry 4.0 and smart manufacturing or connected manufacturing then. So I just move a little bit fast related to these two elements, which is the configurable manufacturing system. I'm not going to explain a little bit detail in this slide because it shows that the importance of reconfigurability in manufacturing industry. And what interesting in this research, you can see that the current state of our manufacturing system, looking at the single station automated cell, automated assembly system, flexible manufacturing system, we can SIMS itself, computer integrated manufacturing system, and also reconfigurable manufacturing system. We can say that among these systems that are available currently in manufacturing, so we can say that reconfigurable manufacturing system is somehow have a better characteristic, which leads or we can extend it into the industry 4.0 then. That's why I really believe whenever we would like to have a real industry 4.0 manufacturing system, it's come from the reconfigurable manufacturing system itself. And this slide I have shown before, and this I already I just try to characterize this thing into digitalization, sustainability, servitization, and also in the middle, which is the advanced manufacturing system, is looking at the reconfigurable system. This is just the element of reconfigurable manufacturing system. This the characteristic shows, and we can divide this into two. The first one is more related to industry engineering, and the second part is digitalization itself. Okay, I do not want to move to this one. This some example. I think I try to skip this one. It's need to be more more deeper in order to explain it. And this is the example of modular smart factory that we have shown the video. So you can see that it's also based on the modularity, and also due to the modularity of this station, it's possible to have a reconfigurable element or aspect. In cyber physical system, it's important because, as I said, we need to have the cyber world and physical world joined together, and then also to make sure that all the elements that were analyzed in the cyber will be transferred to the physical, and the data from the physical given to the cyber in order to have a prediction, and also to make sure that the manufacturing system is optimized. I just want to show maybe one more video before I end this thing. I move forward. This one, this some of the first among the first proposal in terms of how we would like to have a cyber physical system. And I believe this is some video that shows what is cyber physical.
A self-organizing factory that entirely configures and organizes itself and responds to changing requirements, and where humans and machines seamlessly collaborate. This vision is becoming reality in the Siemens Living Lab for cyber physical production systems.
Alexa, trigger product logo echo.
Checking if we can produce it.
The manufacturing of a product starts in virtual reality with the help of simulation technologies. The cyber physical production system first checks whether the production is feasible. The machines in the factory provide detailed information about their production skills and constraints. Based on this information, the system generates a digital twin of the product and compares the required production steps with the production skills of all machines and humans in the factory. The machine gets the knowledge of how the product shall be made directly from the digital twin. Based on the information about how the parts are to be assembled, the system dynamically calculates all necessary steps and carries out the production autonomously. This means that the product steers its own production. This is an important feature of Industry 4.0 solutions. Siemens enhances the skills of the machines through machine learning, intelligent sensors, and speech recognition. This optimizes the production process and increases the quality of the product. Safety requirements are also developed to ensure that people and machines can work together safely. In the future, cyber physical production systems will better meet customer needs and manufacture products in a faster, more individualized, and more efficient manner.
Siemens, ingenuity for life.
Do I have another 2 minutes?
Okay, 2 minutes.
So I have another video that shows that not only the automation system can have a cyber physical production system, but for the manual process also, it's possible to have somehow the connection of CPPS, the functionality of cyber physical production system, and it will help in order to help people to work in this. think I'm not going to let the video end, but what I can explain here is by using this cyber physical production system, it will help to identify which station is going to be used, and also the AGV will bring all the required component to the station, and it will help the operator to assemble and also to complete the process of this product. And so this is another example of cyber physical system, and also before this we already seen the cyber physical production system developed by Siemens. I believe from this you will get some idea what exactly is cyber physical system and why it's really important for the industry 4.0 to have this cyber physical production system. As a contribution, I'm going to show some contribution what have been done. So we already have at the UTeM, University Technical Malaysia Melaka, we already developed some reconfigurable conveyor system, because we believe whenever the station is fixed, it's difficult to move the station. For example, like CNC and so on, it's a big equipment. So in order to cover the flexibility or the changes of the product and so on, it's possible to use the material handling system, which is reconfigurable. So they have some other research related to the cyber physical system for the material handling system, because we believe that based on the movement of the material, we make sure that the path of the process is going to be met in order whenever they have some troubleshoot, some disturbance, so it's possible to change the direction of process based on the material handling system. And we also have some scheduling of reconfigurable assembly system, and we also already developed some integrated approach for layout reconfiguration. So I think I would like to take some opportunity in this summer camp. So in order, you can see that there are a lot things need to be done in order to realize the industry 4.0. Whenever you yourself as a participant of the summer camp Engineers 2022, if you have really interested in this area, why not you come and also contribute in order to develop this kind of technology. Then thank you so much. Then I believe that's all my presentation. Sorry for taking a little bit more time. Then okay, I pass back to the moderator.
Thank you, Professor Azrul, for very insightful material. This is very interesting. So we move to Q&A session. Please, can a committee help us to share the Slido? So there are so many questions. I will take the most interesting one because it get many likes. So since smart manufacturing heavily relies on the internet, what there is data leakage to the public?
I believe from my presentation, you can see that there's a difference between cyber physical system, cyber physical production system, and also Internet of Things, and also industrial Internet of Things. So definitely one element whenever we would like to emphasize or to implement this kind of technology, we need to have the cyber security into our manufacturing system. Then we have to make sure that our data only can be seen to the person which is have authority to see this kind of data. That's why we not company not really like to have their system connected to the internet unless they have a good cyber security system and also they are using their own internet, industrial internet of things. Then I hope that answer the question.
Okay. Okay, for the second question, I will read the second question. As we know, smart manufacturing is very dependent on internet connection. So how potential smart manufacturing will apply in Southeast Asia?
Okay, let me look into a different perspective. If you can still remember from my among my first slide, you can see that the manufacturing required to achieve, or the goal of manufacturing is looking at these three elements, which is time, quality, and also cost. So if you ask me whether is it necessary for our region, Southeast Asia manufacturer, jump directly to Industry 4.0 technology, the answer is yes and no. The first thing, we have to analyze our current system. Is it really going to benefit the manufacturer if they implement the Industry 4.0 technology directly? If the advantages is less than whatever we have right now, I believe let's prepare our system that able to support Industry 4.0, but we still maintain our current system in order to make sure that our profitability or the manufacturing still benefit from this system. Then, so if you're looking at the internet, definitely if you push toward the smart manufacturing which require internet, then it's really necessary to have a good internet connection. We cannot run from the internet connection. We cannot depend on the internet connection which is not stable, because whenever we would like to move toward this thing, we have to make sure that the connectivity is there. It's not only connectivity to the outside, the connectivity among the machine also is necessary then. So why we really eager to move directly to Industry 4.0? If you're looking at the current state, which is before Industry 4.0 has been introduced, in Industry 3.0, people are talking about automation, robotics, computer integrated manufacturing, but some of the companies are still depending on the human, on the manual. Why? Because it's not really benefit in terms of the manufacturing goal, which is the cost, time, and also the quality. And so to answer that kind of question, I would say that if you want to jump to the Industry 4.0 technology, it's necessary to have the internet connectivity, but you have to analyze your current system, whether it's necessary to have or to jump directly towards this smart manufacturing. Either you can just simplify some element which is smart enough, but not the total system that depending on the Internet of Things or internet connection.
Okay, very interesting. So, okay, the next question from Moses Elijasan Pascual. Do you think that Industry 4.0 will be the last industry revolution? If not, then what innovation could spark in Industry 5.0?
Do you think that Industry 4.0 will be the last industrial revolution? So, if you're really satisfied with the current situation, I believe you're not moving forward towards the future then. Even though they have a company that already have a good system and also good architecture that support this Industry 4.0, I believe there's still some challenges that that makes the system somehow at the time is not really applicable at that time then. So I don't think that the Industry 4.0 is going to be the last one. It's going to be maybe there are going to be a future, especially whenever we talk about sustainability. We have to make sure that our resources is enough, not only for the current generation, but our future generation. So if you're looking at that, so I would say that it's not going to be at the end, but even though right now we are still in the middle of the Industry 4.0, it's already 10 years, but you can see that a lot more things to do. And also we can say that maybe at the future we're going to have a new technology that going to surface that replace the internet itself, and also even the network provider also already changed from 4G to 5G, and maybe later it's going to be the size of the processor also already reduced to smaller and smaller size. And I would say that we're not going to end at a certain point, and we're trying to improve step by step.
Okay, so we will wait for maybe it will happen 20 or 30 years, maybe, or 10 years.
Yeah, true. You can see if you take a look at the timeline of the Industry 1.0, 2.0, 3.0, the gap is quite huge, but from 3 to 4, I believe is quite short. So you can see that how fast we are improving our technology, but somehow we need to make sure that it's covered the whole thing. It's not only the industry, but whenever it's involved industry, it will relate also to our life. That's why I believe in some country, it's not only looking at the manufacturing, like Japan, it's already not only manufacturing, but it's focusing also with the society 5.0, something like that. So yeah, it's all about human. We are living here also to manage all the resources in this world. So I hope we're going to have a better future then.
Okay, Professor. Okay, this is one of the interesting question, because we see that Industry 4.0 is all about connection and not in the side of human. So this is the question about from Camilla. Can Industry 4.0 be solution to overcome unemployment rate problem, while the industry is required to reduce number of inputs such as workers? What do you think?
I always think whether whenever I took or changed my education from mechanical engineer towards the manufacturing engineer, and then in manufacturing engineer I focusing more on the automation and robotic. People always say that, oh, you are the one that going to to remove worker from the manufacturing system. But I think even though the manufacturing system is getting advanced or the enhanced, but we are not able to have a fully automated system. Human is still required, and also the intelligence of human definitely cannot be replaced 100% with the robot or the artificial intelligence. But somehow you can say that manufacturing always need support from the political aspect, and in the political aspect they are looking at the employability and also an unemployment rate problem. Then the political of each country will not only let the industry move forward towards this fully automated and so on, but they will make sure that there's a recruitment, or there's a possibility for the worker or graduate to work in the industry then. And somehow, even though we have advanced system in the manufacturing or smart manufacturing, I believe the worker skill also is going to be increased. Maybe it's not necessary to have a lot of operator, but the needs toward the engineer, technician will be higher then, because we need a smart worker in order to operate the smart factories.
Okay, I think that's the last question for this session. Thank you, Prof. Okay, let me resume first what you already explained to us, because our life influenced with many new technology and device is connected to internet and sharing data. So, but about Industry 4.0, the goal still about the cost, quality, and the time. So we cannot jump directly to Industry 4.0 totally.
Yes.
And then Industry 4.4 change the way the manufacturer operates in new product goods. And our country, Philippines, Malaysia, and Indonesia are moving forward towards Industry 4.0. And now cyber world and physical world become together and connect together to make a new manufacturing process. That's okay. That's all about today's presentation. Thank you for coming to ITS virtually, Professor.
Thank you so much, Dan, for inviting me and also to give me a chance to share my knowledge and also my experience then.
Okay. See you later. And thank you for coming. Moderator, giving this Zoom back to MC. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
That is the end of the training lesson 2. For today, we would like to express our huge thank you to UTeM Dr. Ing as well as Azrul for contributing to our event speaker and specific acting moderator. I'm really sure that all the participants get a new insight and fresh perspective.
I totally agree with you, Arthur. All right, let us